Hello everybody. Now it's time to implement the whatever the Boolean algebra laws we have studied or the rules we have seen in the previous sessions. It's time to implement these for simplification of the Boolean expressions are to be there. So let's see step by step. This is our first session in which we will basically cover four expressions to simplify it. And here is the one example, and this one is to be having y is equal to a and b and c, or a and b complement and c, or a and b and c complement. In simple way, ABC or AB complement C or ABC complement. This is also the way to talk about this problem, or the expression is to be there. Now if you look at this expression, it depends on you what you think. The logic cannot be basically to study in that case. You have to develop yourself, but you can develop that logic for the solution. It is possible when you know the laws very well, then you can develop your own logic, sorry. So here is, if you look at this expression here, either one can see AB is the common part for this case, for these two, or either somebody says AC can be a common part. So here it is to be there. So depending on what type of the thinking or the logic you will develop, according to the expression is to be there to simplify. But if you know the laws very well, it is very simple to evaluate or the simplify that expression is to be there. So let's have, if you look at these two terms, ABC or AB complement C, here is the one logic where the AC is the common part we can take, and if we take the AC as a common part, remaining part is B or B complement. Again the third part, as it is term, we will kept at as it is ABC complement. Again, if you know that the law is to be there, B or B complement, that is always one, or you have written A or A complement, that is always to be one, or law is to be there, four or laws are to be there. So for this case I can write one here, and remaining term as it is ABC complement. Again, if you look at this case where it is to be as an having A is going to be the common in this factor, and if you will take A as a common in this case, it will give us remaining part C or B C complement. Here if A is going to be common, the remaining part is C or B C complement is to be there. And again we have seen law number 13 or 14, that A or A complement B is always to be as an A or B is to be there. So in this case also, the variable first and their complement into another variable, if or is to be there, then it is first variable or with the second variable. That is what result we have, rule number 13 or 14, that might be. So the remaining part will be according to that law, A and C or B is to be there. So this is what the solution for the any basically for this term. But this can be solved in a different ways also. Either somebody say AC will be common, somebody will say AB will be common. Again another logic is to be there. If you will take A as a common, it is just those two steps to simplify this expression is to be there. So A will, if you will take common, then again it can be simplified according to that. So related to that, you have for any one expression, there are simplifications are in a different way. The final answer is A and B or C is to be there. Let's move towards the second expression, and that is y is equal to A B complement or C whole complement is to be there. So if you look at this term is to be A, B complement is to be there, or C and whole complement is to be there. So this is what the expression we have to simplify. For this case, the De Morgan's law is to be very much important. De Morgan's first law, complement of sum. Here is sum is to be there, or means sum is going on. But complement of sum, complement कशाची, समची complement. सम कोणती आहे, ए बी कॉम्प्लिमेंट आणि सी ह्यांची सम आहे आणि त्याचा कॉम्प्लिमेंट म्हणजे कॉम्प्लिमेंट ऑफ सम इज इक्वल टू प्रॉडक्ट ऑफ देअर कॉम्प्लिमेंट. मग आता मला ह्या प्रॉडक्टच्या फॉर्ममध्ये ह्या टर्मला लिहिता येते आणि प्रॉडक्ट ऑफ देअर कॉम्प्लिमेंट म्हणल्यावर मला ही टर्म ए बी कॉम्प्लिमेंट होल कॉम्प्लिमेंट अँड सी कॉम्प्लिमेंट अशी लिहिता येते. म्हणजे ऑरचं कन्व्हर्शन अँड ऑपरेशनमध्ये डिमॉर्गन्सच्या रूलनुसार. सो अगेन हिअर आय कॅन राईट फॉर दिस अनदर ए बी कॉम्प्लिमेंट होल कॉम्प्लिमेंट. दूसरा एक लॉ आहे डिमॉर्गन्सचा, कॉम्प्लिमेंट ऑफ प्रॉडक्ट इज इक्वल टू सम ऑफ देअर कॉम्प्लिमेंट. मग इथं जर तो अप्लाय केला म्हणजे व्हाईस वर्साच होतो. जर इथं मी अप्लाय केला तर काय होणार आहे, ए कॉम्प्लिमेंट और बी कॉम्प्लिमेंट अगेन कॉम्प्लिमेंट डबल कॉम्प्लिमेंट. मग कॉम्प्लिमेंट ऑफ कॉम्प्लिमेंट वी नो द कॉम्प्लिमेंट लॉ that is to be original whatever the variable is to be there, or we cannot write double complement, it is always to be as an original value, variable is to be there. So this is what the remaining part, that is a complement or b and c complement is to be there. So this is the way, either you can put in way or you can multiply, that is also the final answer. A complement and c complement or b and c complement is the final answer. So this is what the expression solution for this case or the for this equation. Now here is another one example, and that is simply it is again to be here uh, a or b complement bracket close and b or c bracket close and b for the whole bracket, it is and b is to be there. So to simplify this case, it is always to be better to solve first whatever be in the bracket मध्ये जे आहे ते आधी आपण सॉल्व करणार, म्हणजे त्याचा मल्टिप्लाय असेल मल्टिप्लिकेशन, ॲडिशन असेल ॲडिशन, सबट्रॅक्शन असेल सबट्रॅक्शन. मग ए नी मल्टिप्लाय केलं पहिले ह्या टर्मला, देन आय विल गेट ए बी और ए सी इज टू बी देअर. सो ए बी और ए सी, ए नी मल्टिप्लाय केलं याला, तर पुन्हा काय करणार आहे, बी कॉम्प्लिमेंटनी मल्टिप्लाय करणार आहे बी और सी ला. मग मला काय मिळेल, बी कॉम्प्लिमेंट बी म्हणजे अँड तिथं आहेच, और बी कॉम्प्लिमेंट सी आणि ह्या टोटल ह्याला अँड बी इज टू बी देअर, ह्या कंप्लीट ह्याला मल्टिप्लिकेशन अँड बी इज टू बी देअर. So if you look at this case where the important factor is b complement b, a complement a is always 0, b complement and b is always 0, and law is to be there. So the remaining term will be as it is here, it is shown with this case where it is to be as an ab or ac, or that is becoming 0, or b complement c and b is to be there. Now we will multiply this equation by b. मग a b b with this b, a b c b ने multiply केला, b b complement c or b complement c b is to be there. Again this term b b complement, it's always to be 0, so this term will become to be as in 0. So here it is to be as in 0. So remaining term is to be as in b and b. Here again the another part, a and a is always a, b and b is always b. So the b and b will be, for two b's we will write one b, that's why it is ab or abc. सिक्वेन्स फक्त मेंटेन केला, पुढे मागे लिहिलं तरी चालतं. and this term is already 0 because of b complement is 0, that's why it is to be 0. And if you look at this case here, you will get ab as a common part. ab जर मी कॉमन घेतला, the remaining term will be 1 or c is to be there. So 1 or c, 1 or a is always 1 is to be there, that's why ab and 1, it is always giving you ab is the final answer. So this is what the expression or the simplification for the third expression or the equation is to be there. Now let's move towards another one example. It is x is equal to a b complement and b or c complement. Here is the best way to use this De Morgan's both the laws at a time. You can see it is nothing but to be the first term ab is nothing but to be the complement of product that you have to convert into sum of their complement. and here is complement of sum that can be converted into product of their complement. So this is what the case where you can simplify in this way for using the De Morgan's theorem. So applying here A complement or B complement, and here the sum will convert into product, that is B complement and C complement. So here it is to be the expressions will be likewise. Now B complement C complement will be multiplied throughout for this equation. So the multiplication will be A complement, B complement, C complement, the first term. Now multiply for this B complement by B complement C complement. So this will be B complement, B complement, C. This B complement will be for this, and this B complement, C complement is to be. So this is what the case. Now again, if you look at B complement and B complement, it is always B complement. Likewise, A and A is always A. Likewise, B complement and B complement is always only one B complement. Again here, if you look at this case, B complement and C complement is common here. So B complement, C complement in bracket A complement or A is to be there. Always A or 1 is always 1. Again A complement or 1 is always 1. And here the remaining part will be then B complement and C complement, and 1 is always B complement and C complement is to be there. So this is what the way to simplify this another example. So these are the simplifications for the given expressions. You can take any type of the logic, or you can solve any type in any way. This is not the only one way to simplify that expressions or the equation. You can use according to the what you think. You can develop your own logic. For that, you must have to know that all the 18 rules very well. Thank you for the joining this session. Again, be at home and be safe. Thank you.